So gravitation will discuss now. So whereas gravitation, so force, field, potential, and potential energy, orbital velocity and escape velocity, is Kepler laws. So these are the topics are there in gravitation. So related to force, all the questions will complete. Coming into force, this force is always attractive. And it is vector along the line joining direction. Along the line joins two masses, M1 and M2. Along this line joining, the direction of the force will be there. So obeys principle of superposition. The force is force between masses, independent on medium. Independent on medium. So wherever two masses are there, the force between them is same everywhere. It's a vector. So the resultant follows the vector algebra. Means vector addition gives resultant force. You know, so according to universal law of gravitation, universal law of gravitation, which is proposed by Sir Isaac Newton, the force between any two masses, directly proportional to their product of masses m1 and m. The force between these two masses is inversely proportional to square of the distance between them. Here d is distance, and m1 m2 are masses. So directly proportional to product of masses. So from these two, so F is equal to G into m1 m2 by d square. So this is magnitude of force. And I said force is a vector. So this is mass m1, this is mass m2. So these two centers separated by the distance d. And gravitation force is applicable for all the forces, all the shape of the bodies. So it is applicable for all shapes. But we will consider if it is a spherical shape or ring or rod, the distance you have to consider from center to center. I mean, this total mass is concentrated at the center, mass considered the center. So now on the force, it is like this direction, attractive force towards M. So on M2, the force is attractive. This is towards F2 by 1. This is F1 by 2. So these two are equal and in opposite direction, equal magnitude in opposite direction. So now the vector form of force, the F bar is equal to G into M1 M2 by D cube into D bar. Or in terms of line direction, so this is X cap you consider or D cap. Then F bar is equal to G into M1 M2 by D square into D cap. So this is the gravitational force formula. So if you see here, the G, the term G is universal law, universal gravitational constant. Universal gravitational constant. So the G is equal to the value of G is equal to 6.67 into 10 to the power of minus 11 Newton meter by kg square. So from this I can write dimensional formula of G. So that is equal to dimensional formula of Newton is ml t power minus 2. Dimensional formula of meter square is equal to L square by dimension of kg is equal to m square. So that is equal to m power minus 1 L cube L power means L square into L power 1 L cube t power minus 2 t power minus 2. So that means the gravitational constant dimension is minus 1 in mass, the 3 in length, and minus 2 in time. Dimensions of G is minus 1 in m and 3 in L, minus 2 in t. So now the G value is constant and laboratory calculated by Cavendish. Laboratory, the G value experimentally calculated by Cavendish, and G value depends on system of units. System of units. If units are changing into series unit, the value will be changed. That means power alone changes, and it is independent on medium. Independent on medium. So this is about G. So now coming into force again. Come back to force. The force depends on product of masses and distances. It is calculated for all shape of the bodies. So now I will consider first of all the force due to the gravitational force due to semicircular ring on unit mass at center. So in this calculation will follow. Consider a semicircular ring like this of radius r, and here there is a small mass m, and the mass of the semicircular ring is equal to m percent. Let us consider one dm element here. So this dm element is making d theta, and this is theta. So if you take the theta is here, so if you take theta is here, then limitations of theta are minus pi by 2 to pi by 2. If for this theta, if you take the theta here, that is 0 to pi. So this is a major thing need to remember. And now, as our discussion, this dm mass and m. So this is the line joining. So the force direction is like this. d to dm, this is the force direction. So now here, the df is equal to g into dm into unit mass by r square. So now, if you take another dm here, then force will be like this, one more force due to this symmetrical mass opposite to this center point, symmetry point. So now the resultant force is always in the direction. The resultant of force is due to each element in the direction. That means we have to integrate the force is equal here, net force due to the semicircular ring is equal to integral df sin theta. Because due to the symmetry, cos theta components is cancels. Based on my consideration, theta value, theta where I consider. So now, and here substitute this value, df value. So that is equal to integral df is equal to G into m dm sin theta by r. So now here calculation of dm sequence. So dm is mass of the small element mass. So that equal to lambda into dl. So that equal to lambda into dl is equal to r d theta according to length of the arc. So the lambda is equal to, you can write total mass, given mass of the length pi r into r d theta. Or you can get the answer in lambda also, no problem. So that is equal to m into d theta by pi. So now this value is up to here. So that is equal to, so integral gm into, so capital M by pi r square into sin theta d theta. So now you apply the integration values. Integral 0 to pi I said g into small m unit mass at the center, mass of the ring by pi r square sin theta d theta. So now this will be after integration gm capital M by the pi r square into integration of sin theta is minus cos theta. So integration of sin theta is minus cos theta, I think. So that equal to 0 to pi. So sorry, cos theta, this is plus cos theta only. So actually d by dx of sin theta is equal to cos theta. Integral cos theta d theta equal to sin theta. Okay, it is minus only will come. This is minus cos theta only will come. So that is equal to g into m by m pi r square into, so cos pi is equal to, so minus take comma here, minus 2 will come here, already minus take comma. So that is equal to 2g into mm by pi r square. This is the force formula. So 2g into gmm by is 2 into gmm by pi r square. This is the force due to semi circular ring. So now if you take rod, so force due to straight rod, the force due to straight rod or long rod on test mass or small m we can consider. So test mass is given in the field, we will find out that is equal to 1 kg, we will consider. So now let take this one rod of length L, and this is uniform mass of rod L. So rod L length and mass m, the lambda is uniform, the linear density is uniform, and from here one end to one end of the rod in the distance city there is another mass there. So now let to find out the force means the from center to this mass is equal to distance r consider. So in terms of r we can write, in terms of d we can write answer. So for that, the let dm mass, consider the dm mass in the distance x, the distance x. So now according to gravitational force, df is equal to g into m dm by x square. This is the force between mass and dm. So df magnitude of df bar this is. So now here dm, the mass of small element of rod. So therefore dm is equal to the lambda into dl. So here dl is equal to dx elements, lambda into dx. So keep this one. And now if it is like this, the x is varying to, the limitation of x is equal to d to d plus m. The dm mass is, so now see the dm mass is here to, so this n, the limitation of dm mass are varying to this point to this point. The lambda is varying. So now d to d plus m. Now if you apply this integration formula, so therefore integral df is equal to integral g into m dm by x square, that's all. So that is equal to, so now gm, in the place of dm I write lambda into dx. So integral gm into lambda dx by x square. If you want to write in terms of lambda, capital M by L I can write. So afterwards you can substitute, that is equal to, now limits are d to d plus L into gm lambda dx by x square. Now x square is variable, so g into small m lambda integral d to d plus L into lambda dx by x square. So lambda also comes out only x square. So that I can write x power minus 2 into dx. So if you apply the power rule, so according to power rule, so x to the power of n plus 1 by n plus 1. So that is equal to, I will get here minus 1 by x per limits d plus L, d to d plus L. That is equal to, so actually we will substitute upper limit to lower limit. Here minus is there, na? To eliminate minus, I will substitute lower limit minus upper limit. So gm lambda into 1 by d minus 1 by d plus L. So you have to remember here. So this is lower limit, d minus is there, na? That's why lower limit first to then upper limit. Actually, in substitution of limits, upper limit minus lower. So that is equal to g small m into lambda by the LCM d plus L minus d by d into d plus L. So that is equal to, therefore f is equal to, finally the f is equal to g small m lambda into L by d into d plus L. So this is the force formula. If lambda you are substituting, the force will come like this, g into small m capital M by d into d plus L. So this is with the linear density formula, it is with mass formula. So this is about then two rods are given, means you will go with the double integration. So now the force due to sphere, hollow sphere and solid sphere. So next, force due to sphere on small mass. So this mass, so the distance is less than r and distance is more than r and distance is equal to r from the center. So in these cases you have to find. So all these cases again it will come in field also. So it is better. So if you understand this, you will understand the topic easily. So now let's consider a solid sphere. So this is mass m, the radius r. From the center of this radius, so at the point B there is a small mass m. So you know the force on the small mass by the sphere will be like this. The same mass I will consider here, so which is in the distance r, which is less than r. So this is the distance r greater than r. Right. So now at a distance small r greater than r, consider letter capital M and small m are point masses. Point masses. So that is the F is equal to G into mm by r square in this node out. For r is greater than r. If you take r is less than r, so at a distance, so r is less than r, so you have to consider the effective mass of sphere. So that is, so now come here. So the point is here, the point mass is here, unit mass, and this is m dash. So now m dash will be equal to, means force here, the force I will write. So F is equal to G into m dash, so m by r square. So here m dash is equal to 4 by third pi small r cube into density. So this is the part of the same sphere. So the density is equal to m by the value will come. So that equal to 4 by third pi small r cube into capital M by volume 4 by third pi capital R. So these two are get cancelled. So therefore, the force will be G into M into M small r cube by r square into r cube. So get cancelled. That is equal to G small m into capital M by r cube into r. That means here the force is proportional to r for the point r is less than r. The force is inversely proportional to 1 by r square for the points r greater than a distance greater than r, means outside. So this is outside. So this is inside the sphere. So this is about the force. So now we'll find out the force in different cases. The force in different cases. So that is applications of force. So now first application, let two spheres radius equal radius, two spheres are separated by the distance d, but this density is rho 1, the density is rho 1 and this density is rho 2. So then force will be, the force is equal to G into, the values are equal here. So m1 means density into volume, the rho 1 rho 2 into v square by d square. Okay, so your volume is equal to 4 by 3 by r square. In this case, the force, if d is equal to d in terms of r is given, in terms of r is given, in terms of r, then the force proportional to the value of that one is always. So if you see here, so g into the rho 1 rho 2, so volume square means 4 by 3 pi whole square into r power 6 will come, right? The by d is also in terms of some x square into r square, because d in terms of r, that means d is equal to xr. So like that. So now r square get cancelled. Then we can say force proportional to r power. So same densities are given, or same masses are given. D in terms of distance is given for between two spheres. Then force proportional to r. So this is one. So next coming into second case. Second application, three spheres are arranged like this. So one on another, touching three spheres of equal radius. So then automatically the distance between these two is 2r and they forms a equilateral triangle. So this can be turned into, so there is a equilateral triangle like this, and at each corner there are three masses, equal masses. So that is same. The force on this is 1, 2 point, third point. So they will ask force on any one mass. So that means, so if you take the force on this one is by 2 f2, this is the force on this one is, this is f3, this is f2, and angle between them is 60. And here if you see very clearly, f1 is equal to f3 is equal to f2, and angle between them is theta is equal to 60. So according to vector law of addition, equal forces and angle is 60, direct formula. The resultant f1, the force on 1 by 2 and 3 is equal to root 3 into f. So that equal to root 3 into gm square by the distance is 2r or some l square, right? So l will be 2r. So that is answer. So similarly, the other model of question, another application. So they will give the triangle. So there is the triangle here. So at the center, centroid some mass they will. So at the corners, there are three equal masses at the corners. So now the force is almost they'll ask here. The force on this mass. It is at center, right? G is the center. So therefore force on this one is like this. And force by this mass is equal to in the direction. Force by the third mass is equal to this direction. This is third, first, and the second concept. Now if we see clearly, the angle between these two is 120 will come. Because equilateral triangle, here it is 30. So here also 30. So then automatically this is 120. And here F1 is equal to F2 is equal to F3. So in that no doubt, because equal masses and same distance. Centroid is same distance from the corner side and from bisecting line also same distance. Therefore F1 equal to F2 equal to F3. But if you see the angle between any two forces is 120. So the resultant of any two forces find out. So now this is F1 and F2. The resultant will be like this. So this is the resultant of F1. So and theta is equal to here 120 is given. So therefore that is F only will come, right? The F resultant F12, the resultant of F12 is equal to F only will come according to vector addition. I'm not going to tell how it is coming, right? Root over F1 square plus F2 square plus 2F1 F2 cos theta is substitute means you will get F1. So now the resultant F, so this is F3, and resultant of these two forces is like this. This is also F. Now F3 and resultant force, the angle between them is equal to 180. So the resultant net force F net is equal to 0 with resultant force. When theta is equal to 180, that is 0. So when equal masses are there at the corners or square, whatever the hexagon shape, whatever polygon, any polygon are there, equal masses at the corners. So here at the centroid, when there is a test mass, so that will be force is 0 inside. So this is no doubt at all. So coming into next application, on the same model triangle. So there is a point mass on one of the side. So there is a point mass on the other side here. So position 1, position 2, position 3, equal masses. All are equal masses. So now here to find out the force, so this is the distance will come h. For equilateral triangle, h is equal to root 3a by 2. We know that is. And coming into here, these two are same masses and it is the center point. So this is F1 and F2. So this F1, F2 equal and opposite direction. F1 plus F2 is equal to 0. So in that node. So therefore, the resultant force is equal to only due to third mass. So that means G into small m and the test mass by the height square, that equal to root 3a by 2 whole. So that equal to G into 2gm by 3s. So this is at the center. Means at the not center, at midpoint on any one line. So coming into fifth application, so there are many applications like this. So fifth application C1. So there are 3 points on the straight line, A, B, C, such that AB is equal to BC, that equal to 13 meters. So condition is given, AB is equal to 13, BC also 13 meters. Right. So now the gravitation force on the fourth particle and on at A, at B and at C, same mass is there, same mass. So fourth particle of same mass placing on the distance 13 centimeter from the perpendicular bisection. So here this is 13 centimeter, the bisecting point, here point B is there. From the point B. So now is asking to find out the value of force will be how much on this fourth mass. Right? So now here if you see on B, at A, at M, at P also same mass is placed, same masses. So then an perpendicular bisector is given. So this angle is 90. Very important. Now see, this is the distance between A and P. So the force is like this. So here also force is like this. And here the force is like this. So therefore, so the force, these two, the angle between these two will become. So now this is 90 and these two are equal angles. So these two are equal angles here and here because sides are equal, no? Equal angle. So this is also equal only will come. Think same theta, 13, 13. So same theta will come, right? So that is equal to 45 degrees. And that no doubt, right? That means these two forces angle is 90. The angle between these two forces also 90 will come. So therefore force is equal to force by A on the P mass is equal to G into M square by the distance. This distance is equal to how much will come? Here to here the distance is equal to, so this is 13 root 2 will come. 13 root 2 meter. So that equal to 169 into 2. So 13 root 2. Similarly, that is equal to FCP also will come. Both are equal forces. And angle between FAP and FCP is 90. Then F resultant is equal to D to A and C particles. It will come. Angle between them is 90. Therefore, GM square by 16 means 169 into 2 into root 2 will come. Because angle between them is, you know, that is. Now, if you see the diagram, so due to this B and C, B and P also same direction. So this is along BC direction, right? This is along, the direction is along B, right? Along PB direction. So therefore, the resultant force on the P, the resultant force on P is equal to the force by B along BB along PB bar and the resultant force by AC, that is also along PB bar. Okay, these two are added. So that is equal to, G M square by this is 169, 13 square will come because distance square plus. So this will be GM square by 169 into 1 by root y. So this is the answer. That equal to GM square by, for suppose this 169 they have given as D square. So D value, so D square into 1 plus 1 by root. So values are given, I can say. So this is the answer. So similarly, next application, force I will consider here, means square I will consider. So I will go with some as. So if we consider here square, so square you consider. So all masses are there here. So on one mass I want to find out. So on one mass I want to find out the force. So here the forces are like this. So one is like this, another one is like this. So here the resultant of these two is also in this. The same therefore, and this distance is equal to, this is root 2a. So this is a. These two forces are equal, that equal to F equal to GM square by A square. And the resultant of these two forces is equal to F resultant is equal to F resultant of, for example, this is 2, this is 4, consider 2 and 4. Resultant of 2 and 4 will be the root 2 into GM square by S. And force due to first one, on third one I am finding, the force due to first one equal to GM square by the root 2a whole square means 2a square. So it is along the line joining 3 to 1. So this is also along line joining 3 to 1. So therefore resultant will be added. So the resultant force will be, so Fr is equal to, you will get root 2 plus 1 by 2 into GM square by A square. So like this. So this is one model. So next model see. So there are two particles moving in circular path because of their mutual gravitational force with radius r. So that means here the mutual gravitational force is equal to mv square by r. So you'll ask v is equal to question mark. So now see f is equal to gmu square by the distance between these two will become 4r, right? 2r. So that will be 4r square. So which is equal to mv square by r. So m get cancelled, here r get cancelled. That implies v is equal to root over gm by 4r, or you can take 2 outside. So when you know v, you can find out omega. Omega is equal to v by r. And time find out. Time is equal to time period 2 pi by omega by using this v is equal. And here this v can be tell as orbital velocity. We'll discuss later. Not here orbital velocity. It is right. Next model. So three particles are moving. Three particles are moving in a circular path because of their mutual gravitation. So now this is the centroid of this one. And this distance will become, so now this is the equilateral triangle L, L and L. So we already calculated by the triangle using this. Here the force, the resultant force is equal to, the gravitational force is equal to here also mv square by r. So on each one the resultant will be equal to mv square by r. So the force on this one will get root 3 into f. Yes, root 3 into, because angle between them is 60, these two forces, root 3 into m. So that equal to root 3 into gm square by the L square. So is equal to m into v square by r. So m square get cancelled. So then v is equal to overall root 3 into gm into r. So r is the radius of this circle by L square. So L square is side of this triangle. So now see, this r is equal to, I can write the radius is equal to the center of, means the distance of equilateral triangle from corner to the centroid, that is equal to, so it will be root 3 L by 2 into, so this is how many root 3 L by 2 into 3 parts we are doing. This distance will be equal to 2 times the height. Height is divided into 2 or 3 parts. So 2 to get cancelled. That equal to r is equal to L by root 3 again. R equal to L by root 3. So here you can substitute. So that equal to root over root 3 into gm L by root 3 into L square. 3 to get cancelled. So that equal to the root over gm by L. So here L is the side of the equilateral triangle. So if you want to write in terms of r, that equal to gm by the root 3 into r. So both are equal only. This is the velocity. So like there are 4 particles will go. The similar model, another one. So there are 4 particles are the moving in a circle. The 4 particles are moving in circle under the mutual gravitation, under their mutual gravitational force. So we already studied how to calculate the, so this is a by root 2 distance is very easy, and the side is equal to a. So now force on this particle already we studied. So equal mass is here. So the force on this particle, one particle is, this is the formula, root 2 into 1 plus 2 by gm square. So that is equal to, so fg is equal to here mv square by r. Mv square by r. So here fg is equal to 1 by root 2 plus 2 into gm by s square. So that equal to mv square by r is equal to a by root 2, that equal to a into root 2. So now I want v. So calculate v square. First of all, this simplify. So that equal to 1 plus root 2 into 2 root 2 by root 2 into gm square. So gm square by a square is equal to mv square into root 2 by a. So a square get cancelled, m square get cancelled. So this root 2 will come this side, therefore. So v square is equal to root 2 is coming down, remaining under the same. So gm by a into 1 plus 2 root 2 by 2. So then v is equal to root over Gm by A, I can write this is 1 by 2 plus again root. So this is answer. Small chain. So this is 2. This is root 2. So now answer is, so here 2 root 2 will come. This root 2 will come here. So it is not 2. Whereas root 2 is there, this is 2. And here 2 root 2. LCM is same only, but down is 2 root 2. So now this is 2 root 2 will come. So the small chain here you observe. The answer will be, so V is equal to 1 by 2 into root over Gm by R has to come. R into 2 root 2 plus 1. So these 2. And here R is equal to A by root 2. So in the place of A, I can write R root 2. Then 2 will come out. So here LCM will be 2 root 2 will come. The remaining same only, 2 root 2. So LCM is 2 root 2 is coming. And in the place of R, I can A plus R root 2 I can write. So then it will be like this equation. So this small change of the next model. Model of concept I will explain. Only concept I will explain. So there are two masses they will give like this. Separated by distance d. So the question is when they are colliding. So there will be a collision. Before collision, distance traveled by how much? Distance traveled. How much they will ask? Traveled by each one is how much? So in this case, the collision take place center of mass there, center of mass. Collision take place at the center of mass. Therefore, this one, this is 2. The distance traveled by this is x1, and this is the distance traveled by x2. So now already you know center of mass concept. So then x1 is equal to m2 into d by m1 plus m2. Similarly, x2 is equal to m1 d by m1 plus m2 according to law of momentum that equal to m1 x1 equal to m2 x2. So what is the distance traveled? They'll ask x1. So x1 equal to simply m2 x2 by x1. This is the center of mass. At the center of mass they will collide. And here x1 plus x2 is equal to d. This is the rule. And here when they are colliding, times are same, right? The time traveled by x1 distance and x2 distance is same. To find out x1, kinematics will apply in terms of g and m. In terms of g, I want to means, so x1 equal to I can write half a into t square. Then x2 is also equal to 1 by 2 into, so this is a1 a2 into t square. So now x1 x2 substitute by using these formulas x1 x2. Here I have given x1 x2, that is equal to x1 in terms of x2, and a1 is equal to gravitation force by m1, a2 is equal to gravitation force by m2. Then you can find out. This is one model. So next coming into another model. So there is a one sphere of radius r is there. So here, for example, from this sphere, they are cutting the small mass which is radius r by 2 and placing here the mass. So in this case, what do you do means, so first of all, this is the distance d, center to center, this is the distance d. So in that case, is first to find out the masses, m1 and m2. So m2 is removed mass. So in center of mass, this model we completed. So now first step 1, force by m1 and m2. So now next step 2, force d to m2 and m2. So now subtract. This is consider equation 1 force and it is equation 2. So now F1 minus F, equation 1 minus equation, you will get the resultant force on this point, at this point. When the removing and placing at this point, removing and placing at this point, you will get. Only remove means subtraction, right? Initial mass, and in that case, calculation of the distance is very, very important. So between M1 and M2, here distance is equal to D. Between M2 and M2, M2 and M2, so that is equal to how much will distance will come? So this is D minus, means the total is distance, D minus R by 2. D minus R by. So these cases have to follow very clear. And one more thing. So calculation of mass, I hope you people know, because in center of mass we studied. So calculation of M2 means, so initial mass is equal to M. So in that unit mass you have to find out. So the unit mass is the lambda, sigma, or rho, linear density, areal density, volume density. The into this area or volume are that's all. Okay, na? Therefore, the m dash is equal to the linear density into, okay, na, either area or length or volume, depends on shape. We'll find out. Maximum spheres and disk only they will give. The remaining and all they will not answer. So these are the model of problems. So there are many models. So I hope you understand this type of models. Thank you. Oh, sorry, last model I will tell. For example, uniform rod we studied already. But rod is non-uniform. That means its linear density lambda is changing like ax plus bx square or a plus bx square. So sometimes ax and bx cube, bx square like that will go. So lambda is varying with respect to x. That's all. So now dm is equal to the lambda into dx. So now consider one point mass, and here from x is equal to, so there is a point x equal to 0. This is, and x equal to L. So in the distance there is a 1 point mass in the a distance there is a 1 point mass. So now limits are a to L plus a, right? We know. So here in the distance dm consider means, so dm in the distance x consider means, so now this is a to L plus a are the limits. So now the df is equal to g into unit mass m or one mass you can take, small mass. So dm is equal to a plus bx square into dx. The by the distance is x square. So now integrating from, so df is 0 to f and integral a to L plus a gm into a by x square dx plus b into dx. So now we are integrating, after we get answer. So that is fine. So now see here a into minus 1 by x a to L plus a. So that will be a into, we know already this is, here minus is there, therefore lower limit you have to apply 1 by a minus upper limit L plus a. So that is equal to a into L by a into L plus a. So one integration is completed. Next bx integration, b into x. For b into x into a plus L plus a. So now b into L plus a minus a, L, b into L. So therefore formula is gm into a L by a into L plus a minus b into L. So L also take common, gm into L a by a into L plus a minus b. If you want to keep LCM, you can keep, otherwise you can stop by this.